Hello class, let us try solve the question which I told you I'll be uploading on the channel. This question is about what will be field produced. What will be field produced by a hemisphere at the point shown. This is the point where I want to calculate field produced by the hemisphere. This hemisphere, the hemisphere has got what radius to its merit? R. R is the radius. We want to calculate. What we need to do is we take the element, one of the element which go in forming this hemisphere. So this is the element. We take this at certain distance. You can mark the distance. You can take the angle reference over here. Let's say this angle is theta to us. So at what distance we have taken a disc, a wafer thin disc, we have taken at a distance r sine theta. This is where we are taking. What next we have to do? We have to calculate what this disc will generate at point P. This is the point of interest. So what will this disc generate? We go by what we carry. The disc formula to us reads sigma divided by twice epsilon naught 1 minus cos of the angle alpha. I hope you will be able to relate to angle alpha and sigma over here. Yes, we noticed it is in sigma. Let me write it down in terms of charge then. Q divided by twice epsilon naught into pi r square, where r happens to be the radius of ring. 1 minus cos of the angle alpha. Please remind yourself on the angle alpha, half angle. Making good of our knowledge, let us apply it over here and try find what will this the element for the one, this one will generate at this point. What is the radius of this disc? Radius, as we can read, is r cos theta. What do we then get to see from here is field that will generate is Q. Q is what to me? Q is rho multiplied with volume. And volume out here will be pi. What is volume? Pi. Radius r cos theta. So r cos theta whole square multiplied with, now this is important and I have told you, highlighted this, should have also been taken in center of mass portion. We cannot write the thickness as r d theta over here. We'll have to write as per what we get this quantity as. This quantity is to be r sine theta, and small element, small part of it or thickness will then get me r cos theta d theta. R cos theta d theta. So what we do? We refrain from multiplying with r d theta. You are aware of it. If you do that, you will land getting it for a hemisphere which is hollow. So what from here we will do is r cos theta d theta mark to get me charge. Charge divided by twice epsilon naught and then pi, which are, this is r cos theta, so r cos theta whole square. That's the reason I placed it in r cos theta. The term will get struck. Multiplied with 1 minus cos of the angle. Be very careful which angle you are referring to. This angle is alpha to you. So 1 minus cos of the angle, 90 minus alpha. Let me write one straight over here. What will that be? 1 minus cos of the angle, 90 minus alpha. What will that be? 1 minus sine of the angle theta. 1 minus sine of the angle theta. Because it's cos of the angle 90 minus theta. So 1 minus sine of the angle theta. Pi r square on what we get to see from here is rho divided by twice epsilon naught. R as it is. So r I keep over here. Cos theta into 1 minus sine of the angle theta d theta. This is what we get? Rho r by twice epsilon naught bracket open. Then first one is cos theta d theta. Second one is cos theta sin theta d theta. Fair enough. What then? Rho r by twice epsilon naught. I presume it is not freezing. Okay, it's continuous. Good. Rho r by twice epsilon naught bracket open. We need to integrate cos theta. Integration will get us, as you know, sine of the angle theta. Then we need to integrate sine 2 theta. This can be written as sine 2 theta by 2, which when integrated will get me sine 2 theta by 2, right? This one. 2 multiplied 2 divided. So sine 2 theta by 2. 1 by 2 is already there, and you are to integrate sine 2 theta. So sine 2 theta when integrated, what we are to get? Minus of cos 2 theta. Minus of cos 2 differentiate and see. Minus of cos 2 theta. Minus when you differentiate cos 2 theta, you will be getting sine 2 theta, and sine 2 theta with a negative sign. What else you will be getting? This is important. What else you will be getting? First you will differentiate this with respect to theta, 2 theta, and then 2 theta with respect to theta. So what else you will be getting? You will be getting 2. And that 2 will come over here. So this should be divided by 2. Check class. It's your integration skill now. So this is what we are getting. We are to place limit from where to where theta should vary. See point also from where to where theta should vary. Not to take entire into consideration. Theta should vary from where to where. From 0 to pi by 2. From 0 to pi by 2. This is what we are getting. Rho r by twice epsilon naught bracket open 1 minus 1 by 4 done, and minus plus if we take bracket open over here, what then we get to see is minus 1 and minus 1 again. We check class. Okay. What we are left with then? 1 minus 1 plus 1. So 1, 2, 1 by 2. Which is to get us 1 by 2. So 1 by 2 is what we are getting over here. Placing rho r by 2 epsilon naught into 1 by 2. We get rho r by 4 epsilon naught. This is what we will be getting. It's lagging now. Thank you class. Thank you for being